Hi everyone, welcome to Aduro Clean Technologies live corporate webinar. This is Colby Mintram from Bolt Strategic Partners. Aduro Clean Technologies is publicly listed on the CSE under ticker ACT and on the OTCQB under the ticker ACTHF. I have Ofer Vikis, Chief Executive Officer, and Abe Dyke, VP Strategy and Business Development on the webinar with me today. This webinar will be recorded and posted online for replay purposes. Please note that this webinar will contain forward-looking statements. For the full disclaimer, please read slide 2 of the Aduro corporate presentations. Please be advised, Bolt Strategic Partners is not a registered investment advisor or broker-dealer, and more information can be found on our website at boltstrategic.ca. I'll now pass it off to the team, to Abe and Ofer to give their presentation, and then we'll be hosting a question and answer period at the end of the presentation.
Yes, hello everyone, good morning, and thank you for having us. This is Ofer, I'm the CEO. I'm guessing there'll be in this presentation some people that already been seeing it and some new members. For those who has been seeing it, just be kind with us and be patient. We'll try to go as fast as we can. For those who are new, we'll give you as much information, which I hope will be also as excited. We left some time for Q&A with the hope that you will ask questions. We did receive some questions out there that are intriguing and interesting, and we'll try to answer. Not all of them could be answered today due to some confidentiality issues, but we will try our best. With that, again, I thank you very much, and I'll let Abe start the event.
Well, thank you. Thank you, everyone, for meeting with us today. Today, we'd like to talk to you about our company and the proprietary chemical conversion platform we've developed that we believe will be a disruptive force in several industries. So let's move on to the next slide. So Colby already identified our forward-looking disclaimer. And as he mentioned, you can find more information on our SEDAR filings and on our website. Next slide, please. So who are we? Aduro Clean Technologies is a Canadian company founded in 2012 with an adjunct research team at Western University in London, Ontario. In that 10 years, we've developed 7 patents, 3 of them that we've published, 3 that are pending, and 1 that we procured. The development of these patents support our hydrochemolytic chemical conversion platform. Once proven and commercialized, hydrochemolytic technology will address several global challenges. Initially, we're trying to apply the technology to 3 separate verticals. First, the bitumen upgrading. In this market, we are looking at heavy oil, specifically Alberta crude, and applying the hydrochemolytic technology to break down heavy hydrocarbon molecular chains, and generate higher grade petroleum. This can reduce the need for adding diluent for pipeline transport, translating to operational cost savings while reducing carbon footprint. Diluent demand in Canada has tripled in the last decade, representing a 750,000 barrel per day market. The second area is in renewable upgrading, where we take the renewable oils such as soy, canola, corn distillers oil, camelina grown on marginal lands, tallow, and indeed used cooking oil to create things like renewable diesel, sustainable aviation fuel, and other renewable-based chemicals. The global liquid biofuels market is projected to reach $219 billion by 2027. The third area we're focusing on is plastics upcycling, which is a huge opportunity. Our process can take the complex molecular structure of end-of-life post-consumer plastics and convert them to simpler components that can be used to create new plastic products. This addresses the growing attention towards circularity. So what is hydrochemolytic? We've coined the term hydrochemolytic, hydro since it uses water, and chemolytic referring to chemical deconstruction. Aduro is reimagining the deconstruction of molecules. Traditional approaches have been thermolytic, heat-based, such as gasification and pyrolysis. Our technology proposes a new, more chemically advanced approach towards upgrading low-value crude oils, renewable oils, and all families of polymers, which include waste plastics. Simply, what it does is realigns the complex molecules of hydrocarbons to create simple molecules that can be recycled or redeployed as the building blocks for new materials. We refer to this as discriminate process, which enables a greater chemical flexibility of the original material. We use this term to contrast other methods which are indiscriminate. This uses high heat. The use of high heat limits recycling and upgrading options. Think scissors selectively cutting chemical bonds versus a hammer smashing those chemical bonds. Both work. However, with the scissors, you can choose your outcome. This is the breakthrough in hydrochemolytic. Next slide, please. So a little about our story. As you can see, we've been very active over the last 10 years in advancing our technology. We took the initial bitumen research to Western University and advanced it through a series of experiments, initially to perfect bitumen upgrading aspects of the technology, then took a look at the possibility of using other feedstocks as ingredients in our process. Through that research, we developed pathways for renewable diesel, biojet type fuels. This led us to submit patent applications on renewable and vegetable oil-based fuels. In 2018, we again sought to perfect sought to change to a different feedstock. This included rubber tires, plastics, polymers. Our success here demonstrated that we had developed a comprehensive chemical conversion platform with a potential for very broad applications. In 2020, we took our research out of the lab and are now in the pilot stage. We've moved our operations to Sarnia Lambton Research Facility and are setting up our R2 unit. This is our first milestone that you guys have been hearing us talk about. This is a continuous flow process unit that we are going to demonstrate bitumen upgrading on. This represents a decade's worth of work, nearly $4.5 million worth of both equity, time spent, friends and family rounds of funding, and indeed, as you can see, many grant applications through NSERC, OCI, BiofuelNet, and then collaborations with Western, Greenfield, and more recently in the Western Sarnia Research Facility with BIC, the Bioindustrial Innovation Canada. Next slide, please. Here you can see the core team that has developed the advanced hydrochemolytic chemical conversion platform. Our founder and CEO is Ofer Vikas. He's an entrepreneur focused on technology. Over a decade ago, he came across bitumen upgrading research conducted by Dr. Norbert Berkovich. Brian is his son, who did the work at University of Calgary. This research forms part of the patent portfolio that we have. With Marcus, he founded Aduro Energy to continue the research and build on chemical conversion platform. Marcus is a recognized expert in optimizing industrial processes. He's our CTO. His research has generated numerous patents, and he is the author of all of our patents. He's an expert in the field of chemometrics. This is the science of extracting information from chemical systems by data-driven means. As for me, I come from an oil and gas background, having built pipelines and compressor stations, everything related to downstream oil and gas infrastructure. I've also built renewable projects, wind and solar, waste to energy, and biofuels projects. Donica is our CFO rather, and he has held a number of senior finance roles in private and public listed companies. He's been instrumental in navigating our RTO process. And Neil joined us from Western University and has been on the front lines of our research in the past 7 years. He worked closely with Marcus in advancing the technology. As we move to fully demonstrate the technology and eventually commercialize, we will grow our team. I'd like to now turn our presentation over to Ofer, our CEO, who will walk us through the landscape of the technology that we're working in.
Thanks, Abe. Hello, everyone. The goal of this presentation, of course, is to show you how we're different. There's a lot of questions about how is the technology operating. We noticed that, and we want to show how we're different and why we're different. And that obviously will open up the gate to the potential opportunities that are lying within the technology performance. The technology is about 10 years old, and it's very, very early in considering, when you consider chemical workout. Most of the technologies that you are aware of today, the background is over probably from 20 to I'll say 50 years, if any, even more. Sorry. With that, I'll start. basically what you look here, our landscape. So we'll start with the landscape perhaps. The graph that you see here, on the left are material that is desirable, that it has higher value and less undesirable component. As you go to the right, these long chain heavy molecules become longer and longer and gain much more undesirable components. Some of them are human-made, like plastics. Some of them are nature-made, like asphaltene, and somewhere in between, the renewable oils. The goals, of course, is to reduce the molecular chains in such way where you will get rid of the undesirable characteristic and stay with the desirable. In other words, increase the value, reduce anything else. And the goal to do it is by the simplest or the most cost-efficient way to do it. The problem that we have today is within time, as waste is going and gathering all around us, we're facing more and more issues that are man-made. In other words, there's more pollution, and the material that is available, used to be available maybe in a well, is now scattered everywhere. And so it's now gaining negative costs as well. So in a way, we are dealing with new problems, not just an old problem, and all we have to solve it are somewhat of an old technologies, or what we say, last era technologies. The graph represents the size of molecules. So anywhere between 0 to 50 are the molecules that are really the one with the high desire that we pay money, and anything between the 50 and above is really a components or material that we have to somewhat work and operate on. This goes with the, asphaltene is part of a heavy oil that is, available a lot in Alberta and also in the rest of the world in some components, in some areas. And it's been growing in production. Renewable oil is something that we've been, working on, society has been working on the last 30 years or so, I guess, that has share the same characteristic. And recently plastic has been, we've been overwhelmed with plastics, but it's a human-made polymers or molecular chains that are engineered in many, many ways and really, really hard to deconstruct. Next slide. So what's the challenge? Over the years, there were maybe 3 approaches or concepts to do to work and solve those problems. Of course, we're coming from what we call the linear economy, where we use things, they were available in vast amount of quantities, and then we simply use them and dump them. For many years, we did the minimum, and the minimum would be just a landfill, or we use plastic by reuse by blending. Sometimes we did some mechanical breakdown. That means we try our best to not add cost into it and just do whatever we can after using it to solve the problem. In today's time, society has much less stomach to deal with it, and really is looking for solutions to kind of reduce the size and the footprint of landfill. In addition, we today tends to see those landfills as assets. In other words, there are there's vast amount of hydrocarbons that are there that we could use. The question is how we can use them. The second approach, which is the more common, and we're talking about conceptual approaches, is the heat-based that Abe mentioned about. The heat-based goes is actually divided in the cross-border associated with each of the sectors. So the heavy oil, the plastics, and the renewable. Each one of them has a heat-based operation. For this discussion, we kind of minimize it to the plastic, which is the simplest one to show, but all the others use more or less the same. Basically, if you want to do something over the last decades ago, you would heat it to such extent that you would crack the molecules. And when you crack the molecules, you create all kind of issues. The material that you have now is not organized, is not pure, and you have to deal with issues that are related to post-processing or pre-processing. It has a lot of undesirable characteristic, and it basically increases the costs and capitals that is required to deal with it. The thermolytic approach, which we call the heat-based, are associated with gasification, pyrolysis, things that you are maybe familiar and you heard over the years, and things that perhaps today with the chemical approach, has less flexibility to deal with those issues. The last and most advanced approach, which everyone are looking at, is, of course, the chemical recycling approach. This is where we start to come in, and we put here just a set of approaches that are already available, but we call them limited chemical recycling. The reason being is that for most of the time, this chemical recycling was associated with a specific process. By way of example, imagine a car manufacturer that has a lot of plastic waste, and it's very unique. It's characterized in the same way, and all you have to do is just take it back and reverse it to the plant and do some solvent recycling in order to reuse the plastic. Our approach in this sense, it's much wider. Sorry about that. The technology is able to solve multiple type of feedstock and turn it into either higher value inputs that are associated with the circular economy, or turn it into fuel, all in a much lower temperature and intensity that the thermolytic approach are doing. Hence, it's simpler, it's much more friendly, and it's much more cost effective. Next slide, please. So again, this is on a broad scales, items that are associated with certain realities that are coming from the bitumen, the plastics, and the renewable. Often what you will see, because of the issues that I discussed before, the efforts to process and deal with what we call macromolecules on a large scale, and because you have to suck every cent out of it, you end up to be with high capital cost. Normally, you're bound to do some large scale operations. You do have to deal with byproducts. You have a high energy intensity, and when you have high energy intensity, you have things that happens. You simply, I'll call it burning, although it's not burning. It's just hitting it to such extent that you have to crack everything, and obviously you have to deal with the emission of it. Those are all. If there is a technology that could reduce all of that, then you can see the power of the opportunities, of course, because of that. And the petrochemical refining was relying on those activities for many years. I'll just remind everyone that we are just an early stage. We're young in this case, but we are converting in a way that perform maybe a chemical conversion. And for that reason, we are reducing significantly all the above components. And hopefully we can show it to you as we move forward. Next slide. So hydrochemolytic, Abe mentioned hydrochemolytic. So what it is, it's a water-based which involve chemical deconstruction of complex micro molecules to simpler component. The difference, I'll say that when we are doing this chemical conversion, we stay very much with material, with molecules that are similar to the original material that they started when they were part of a major component. That is not the case with the thermolytic approach, and this is very, very different because it allows us now to imagine opportunities to direct those molecules to different direction. Hydrochemolytic, it's a deconstruction of macromolecules in divert feedstock, and we're doing it by agency of water. In many cases, we do not need other resources that are normally required in other approaches. And the reason being is because we are creating them in situ. Think again on the process. We are creating this, we're looking at the material from its chemical content, and basically we're enabled to build it up, our needs. And so in the waste, there is enough material there for us to be used and to create reactions that are equivalent to reactions that saves the need for hydrogen. So for most of the time, by way of example, hydrogen is required in all of the processes that I mentioned to you in order to further stabilize the output material. In our case, we are creating reactions, actual reactions that replicate as if there was a hydrogen there. It's not a molecular hydrogen. it just replicates it's creating a reaction that is similar to what would have happened if we would use hydrogen. Hence, for that reason, we do not need to use hydrogen, and that's a big ticket item when you're thinking about the environment, because hydrogen is used, for methane reforming, and is associated with a lot of environmental issues as well. Next slide. So if I would try to ask you to imagine a petrochemical process, normally you would think of something very, very complex. This is, by way of contrast, is a water-based petrochemical process. It's the platform is water, and just water alone at the temperatures that we're working will not do anything. We're working at temperatures that are way below, the closest reaction that you would think of, to create something would be over 400 degrees, and it required catalyst and some hydrogen generating. So we're working at 360 on average, and that's way, way below. So simply hot water. So what reaction you would create there if you will not have additive components? So it's a catalytic process that has somewhat of a hydrogen donor that is derived from biomass, but it's basically based on water, and that's create a profound simplicity of the process. And by way of example, if I'll take just plastic as an example, it imply the same for the heavy oil and for the renewable. Think of plastics as a mixture of different chemical components. And so they are subject, of course, if you subject them to the same conditions, they will react differently. And so you need to find a way to approach that. And so in this reactor, if you considered the lower bottom of the reactor where we're putting something like a mixture of plastics, we'll subject maybe the first section of the reactor will be subject to a maybe lowest severity, and some material will be moved away, and we could aggregate it. And then we'll take the more stubborn material and subject it to another severity, a little bit higher. And then some good materials will come out of it. And then we will subject the rest of the reactor, the more stubborn material, to a much higher severity. And now we aggregate the material, and the output is quite large. The yield of it is quite good. And the reactor, in a way, is sorting the material. So the technology, by the way it's building, is assisting us in the pre and post processing treatment. Hence, we are saving a lot of the capital costs associated with that. The technology does require a certain material that is derived from biomass, or from material that is available normally in abundant waste near the area of the collection site of the plastics, if we'll put a plastic as an example. And we are mixing it with the reactor, and we are creating what we call a hydrogen equivalent reaction that are replicate as if we would use hydrogen molecules. And here is the profound significant and change, because it makes things much more simpler and much more economically shorter in capital cost. And as you can see from the sketch that I've showed you now, just a simple process. Before one more comment on the sketch. Over the years, we have learned lessons learned from bitumen have moved to the renewable, and from renewable moved to the plastics, and altogether we've gained our intellectual, I'll say, advantage. I'd like to say that the design of the reactor is quite boring. The secret sauce that we're using is basically in the chemistry. And so in general, we have an optimism that the reactor design and the issues that are concerning to scale up should be easier. And the optimism comes from what you see here. It's a much simpler process to scale up. The secret inside is just the chemistry that we've been working for some time now. And I'll say that the chemistry that associated with that, the science behind it, has no question. The question is, why and how you can scale it up. And to that, I'll say that you can scale it up because overall, it's operate in a much simpler scenarios than anything out there in comparison so far to it. So it's there is an optimism there that you can perform in a much better way, in much economical way, in a much higher yield and higher efficiency. Next slide, please. So as I mentioned, the benefits are that we're talking about are embedded in the not the design, but in the chemistry that we have. And so some of them are mentioned here, the financial elasticity. So basically we're talking about system that, you know, its starting costs are much lower than the equivalent nearby system. We're talking about around 1 to 10 in size. And that gives you an advantage to move around and place the processing unit perhaps in areas that are not ideal to a vast, large scale-up operation. That also gives you the opportunity, if the market is changing, to ideal your system or to increase capacity as you see fit. And there is a lot of capital cost saving that associate from the process itself. And so there is much more capability to deal with in today's scenarios that as we've been seeing in the last 2 years, you know, they're just really sharp in reaction. The system is much smaller, as I mentioned, about 10 to 1 in size from the nearby process. It's much cheaper. We're looking at costs that are, you know, I'll say from the heavy oil, by, you know, based on the heavy oil industry is measured by how much money you would invest in order to upgrade a barrel. So an upgrader of 100,000 barrels per day or so will cost about $1 billion. So $100,000 per barrel in that sense. We're talking about investment over $10,000 per barrel, just by comparison. So, you know, if we're wrong, it will be $15,000 per barrel, but it will never be as high as $80,000 to $100,000 per barrel. This is where current upgrading technologies sits in. The efficiency of the system is quite profound. If you think of it, we're using lower temperatures. We're using basically lower conditions, and in lower conditions, nothing happened with hot water. They simply, you know, you just heat the water and that's it. You can't do any reaction. But if you use the input material that I mentioned before, then you're getting really, really nice yields. And we're talking about yields that are closer to the theoretical limitation that we see already in the lab. And so, you know, by way of example, we've run tests on polyethylene recently, and we reached, and this is a pure material, and we reached a purity of 98% and efficiency of 90%. That means, you know, when I'm thinking about a competitive in the market, there is one example that I can mention, perhaps produced by Procter & Gamble, that is doing some kind of a solvent conversion for polyethylene. And we can do the same, not just for polyethylene. We will do the same for polypropylene, polystyrene, and we have solutions to deal with most of the families of the polymers. And so the system is quite efficient in comparison to its size and its cost. It's scalable, and it can scale up rather than scale down. And what does it mean? It means that we really can provide solutions dedicated to a territory. And you know that when we're speaking about, again, I'll speak to plastic, but it's some similarities goes well to the renewable and to the heavy oil. Different sites are associated with different type of waste. Polymer could be, in Toronto, polymers will be probably more sorted, and they would probably will look into some kind of a circularity. But in Mexico, by way of example, polymers will be a bunch of mix in vast quantities, and probably the most reasonable way to deal with them would to move them into crude. The system is scalable from small to large in ability for us to associate a solution in either a remote site or a closer, you know, or a closer nearby site where we need to grow up. The emission of the systems, or the performance of the system, is quite profound in terms of the energy used, plus the energy that we're getting, and some of the emissions. We're talking about numbers that are are really impressive. We're using no more than 10% of whatever the amount of the energy that is stored in the material that we're using. So kind of a low energy intensity operation. And if you're using only 10%, how much emission you can produce from that? And so numbers vary from anywhere from 2 to 7%, depending on what we are doing. And on the other hand, the stakeholder, everything that we are cutting on the way. So if it's blending, or if it's upgrading, or if it's the association with transportation emission for plastics, everything else, we're saving so much emission that the life cycle assessment of the unit is really, really impressive. I'll move to the next slide, and I'll say this, that the byproduct here are very minimal, because we're using low temperature, because we're using chemical conversion. Everything that's embedded in the system allow us to reach higher yield. When you do higher yield, you have very minimal byproduct, if any. And so in the heavy oil, it goes to a little bit of small amount of solid and cokes. There is some CO2 that comes out. In the plastics, it's really almost nothing that is come out of there that we can see. Next slide, please. So what's the market that we are approaching? All of those markets are very, very large. And so at this point of time, we are in the stage where we have to prove the technology, we have to demonstrate it. And we're looking at the market from a really 10,000, well, I'll say 100,000 feet. As time is passing and we're narrowing down to each market, we will dive into developing the appropriate business model that associated with that. For now, the heavy oil market is quite large. As you can see, the waste plastic market is significantly large as well, and the renewable as well. We have solutions that associate with each market. The bitumen upgrading, we think that the bitumen upgrading is appropriate for the Alberta, but it's also appropriate for installation in refineries, because asphaltene, we are attacking the asphaltene components in the bitumen, and asphaltene is about 20% of a barrel, and this is just an example for the efficiency of the system. But when you are operating in a refinery, what you call the bottom of the barrel, after this whole process, still you get material that we can deal with, and we can return it back to the refineries, and refinery can increase performance of it. So our solution is not just for Alberta and heavy oil, but we also intend to sell the solutions to refineries. The plastic upscaling, the benefit there that we can see right now is that the fact that we can use it in small and large scales, and in scenarios that we have a mixture of polymers, and in scenarios that we have a more sorted level of polymers. In both cases, we have solutions. And really when you think of the plastic side of it, I think we want to do the capability of the system, because of its size, is to address areas where, maybe a waste is just before it's been shifted to the landfill. In other words, small businesses that we can operate with. We see that opportunity that we can operate with small businesses and take feedstock that will never reach the landfill before it even reached the landfill. So most of the organization are thinking about, a business model where you have to build large quantities of massive operations and offtake agreements and all kinds of things that are associated with that. We think we can tune solutions to businesses in a much smaller scales, and by this avoid the necessity of moving this feedstock into the waste stream. And the renewable upgrading is another application that we have. And again, it sounds like we have we haven't jumped from flower to flower when we are developing the application. In other words, we have investigated the heavy oil, and then we moved to renewable because we knew there is benefits there, and lessons that learned from A to B moved later to the plastics operation as well. And even today, we're improving our approaches. I say that because the renewable is very much, it's a bit of divert from what we are doing today in the plastics and the bitumen, but it has, we have solutions that are associated more with the customer. So ethanol, by way of example, producers that are feeding on corn, and have a byproduct of corn oil, we can help ethanol producers to increase efficiency by using the waste corn oil into some kind of input material. It could be either chemicals, or it could be some kind of a biojet fuels, or drop-in diesels. So significant opportunities in each sector. Each one of them is very, very different. Next slide. So describing the technology and talking about the ability of, its profound ability, always raise a lot of questions. And over the years, we've been staying a little bit under the radar. We try to minimize our social footprint, if you will, because we were very, very vulnerable. But it raised a lot of questions of how we're doing, what we're doing. And so the answer to that was building the demonstration unit, the showroom unit. And I think we gave it about 6 months, and we're getting closer to the end of this time. But we're commissioning what we call a showroom unit in our lab in Western University. And we will commission another one in Sarnia. So we will have at some point of time 2 of them. And the focus will be to not just demonstrate the technology and confirm the science behind it and show it to the world, but also prepare the technology for sample demonstrations. And so there is a lot of skepticism around the petrochemical industry. They feel they know everything, and that's right. This is a veteran industry, it goes as probably as about 200 years old. And so the easiest way is just to bring them for demonstration. So in the next 6 to 12 months, we will be focusing on bringing customers that will help us to co-develop the unit in each sector. And we don't need more than one system. We're actually going to build 2, but we don't need more than one system. The same system in different variation can operate actually on all feedstock. It's not an easy, but it's very cheap, if you will. And as a market opportunities will approach, we probably evolve and direct more resources to a specific direction. At this point of time, in the next 6 to 12 months, after commissioning the showroom unit, we'll be focusing on bitumen, which is the one that we started, and we are closer to the end of the research of it. And we will move on demonstrating of plastics. And the demonstration of plastic will be on a single stream, perhaps one that is, of a certain type, or even a mixture of plastics. And each one of them has different benefits. When you're talking about a single stream of the plastics, you can actually, with the help of the system, produce input material that could go later to the production of new plastics. So full circularity, and it's profound advantage for some customers who are no longer interested in the pyrolytic approach. There is a lot of pyrolytic approach, but customers that we see are kind of a less of interest of them because they cannot claim environmental benefit because of it. And we are definitely providing these opportunities. And in areas where you would see more advantage to, let's say, producing a fuel, and I gave the example such as Mexico or the other areas across the globe, we will probably focus on more of customers that are interested in some kind of a saving or gaining out of their waste. And so the opportunity is to bring them into the lab, to get some samples, to analyze it, and to work with them to develop solution that is dedicated to these guys at all. In particular, at the end of it, we will be focusing on the larger scale, which I'll say that are more associated with the commercial application, but this is beyond the 12 months period. Next slide. This is a good time to maybe move pass the conversation to Habe, who can speak to the ESG and the benefit that the technology represent.
Yeah, thanks, Ofer. I'll give you a little bit of a break after all those slides. So there's a rapidly changing regulatory environment. And I think as if you guys have been hearing us talk about the 3 separate verticals and what is our application and opportunity into the market, we see a number of regulatory events that are happening that are translating into real opportunity for us. More so than just us being able to do it more technically favorable, meaning that we believe that our technology would actually be commercial ready and competitive without some of these regulatory frameworks creating additional benefits. So what do I mean by that? So we're rapidly moving from a linear economy towards a circular economy. So globally, we're looking at how to go and take our resources and bring them into circularity rather than just ending up in landfill, meaning that those resources are going to create more value. We're seeing that there are low carbon fuel standards, so demand for liquid biofuels. So that's in Canada, and the US, and in Europe. We're looking for biofuels. And in some places, you know, Ofer is mentioning places like Mexico or places where, you know, there's a demand for liquid biofuels or liquid fuels that can be used instead of, you know, having them be transported, have them produced locally, avoiding that long distance transportation. There's you know, as we're moving out of COVID, you know, all countries are looking at infrastructure spend. And with that infrastructure spend, they're increasingly focused on making it towards clean tech, and making sure that the infrastructure that they're building is going to have a lower carbon footprint. And so all of this speaks to, you know, a greater opportunity for us to bring innovative new solutions to how we treat long chain hydrocarbons. I'll give you a couple more examples. They're not on this list here, but you have the oil sands path to net zero. So in Canada, the 6 largest oil producers have gotten together to look at how do they develop a path to net zero. So they're looking at carbon capture, but they're also looking at other innovative technologies. And this speaks to opportunities for early stage technology companies who are looking at a more innovative approach to dealing with long chain hydrocarbons. You've also got the Airlines Association. So CAFE, which is an association of airlines that are looking at, so it's the Commercial Aviation Alternatives Fuel Initiative. So the industry itself is looking at how to go and create renewable fuels for its industry, and really creating that demand, which is the pull, rather than the push, which is coming from regulatory agencies like government. So I think from this, you'll see that we're entering a stage where there's a great opportunity for Hydrochemolytic and our innovative approach to long chain hydrocarbons deconstruction. With that, I'll pass it on back to Ofer.
Thanks, Abe. I think I'll end up with these slides, and I'll let Kobe continue and talk a little bit about the finance that's behind the company. This slide speaks to our, you know, conceptual business models, and we're looking at licensing mainly. We can provide, we see the opportunity to provide dedicated solutions in dedicated areas, and so we think that is the easiest way approach to do that. There is a core team that has been dealing with the know-how for many, many years, and so it will be very, very, it will be very good to keep the company lean and selling those technologies, licensing outside. We also don't want to have it on the books, as we think, and we hope that we'll sell quite a lot of those. So licensing is the one that we think will go with it. We recognize that there could be different business models in different sectors. The heavy oil, by way of example, is more of a pay for service, and they like us to, they probably would request us to do something different than is licensing. But that is what we are considering as so far, with the intention that it may be changed as we are narrowing down into the business model. The units in general has anticipated lifetime of over 20 years. And the cost of the unit over those 20 years seems to be really impressive. So we're looking at ROI that is anywhere between 3 to 8 years in general, and over 20 years the farm performance of the business model should return in profit as you can imagine. With that, perhaps I'd like to pass we do like to have questions, and so maybe Kobe, could you pass it to the next slide?
Yeah, for sure. Thanks, Ofer. So share metrics. So we're looking at 33 million basic, 44 million fully diluted, high insider ownership. There's 10.4 million warrants outstanding. Cash position will obviously be updated as of the next quarterly financials, but as of last count, there's $3 million in the bank, sitting at around $28 million market capitalization. Any more specifics regarding the share structure, feel free to reach out to Craig at ir@adurocleantech.com. So here's the sector. So I think everyone on this call is no stranger that the Cleantech sector, is a majority of them that are trading on the junior markets are pre-revenue, and they're commanding, $100 million plus valuations. Some of these companies are ahead of Aduro, some are behind Aduro. So we at Volt think there's obviously significant growth opportunities for Aduro over the next 2 years in this sector to fill in that valuation and reach the potential. Most of these companies are, they're not specific competitors, but they are commanding all $100 million plus valuations at a pre-revenue stage, similar to Aduro. And for that, we will open up the question and answer period. So we have some questions already posed, so we will answer them, as they come in. So, Ofer, out of the 8 elements on the benefits slide, which ones are you guys certain about, and which ones need to be confirmed via testing and pilot plants?
The elements of the, it's the science suggests that we are, the benefits are really associated with the scale up are, I'll say, simple. We don't dare to say that because we're talking about new and old. So, over the last 100 of years, you would need to go into different size of pilots because of, the risks associated with that. We feel that the scale up will be really somewhat of an easy. I think that we will face more issues that are associated with the items such as supply chain and things of such. So I don't think that the benefits there, some of the benefits there are the one, that are, I'll say, at a higher risk at this point of time. Saying all that, it still has to be, when you scale up from small to a larger, you have to follow a process and you have to prove each stage. And so with that, we feel quite comfortable around it, but it does has its challenges.
Perfect. So next question, are there any unfavorable secondary reactions that could be a concern when scaling the technology?
A great question for the, I guess, a little bit more technological. So far we don't see, and whatever we see in the bitumen, we have issues that are associated with H2S and things that are required some kind of a handling. So nothing that is coming out that we are not aware of at this point of time. So far, we haven't seen anything in the process that triggers red flags in the technology from that perspective. We see other issues that we'll have to deal with going forward into the future, but not from, we feel we are aware of what we're dealing with at this point of time.
Perfect. So how much pre-sorting of the plastic feedstock is required? Can you take all the plastics, most of the plastics, some of them, or do they need to be separated?
Yeah, this is a great question. Everyone is caring about plastic, and plastic is close to us. It's everywhere, all around us, and when we look at it, we know that there should be another way to deal with it apart from just bury it or burn it. This is a learning experience, and so understand that the technology is fairly new, and so there are things that are straightforward for us that we know that we had already a huge success. By way of example, the polyethylene. And we know because of the chemical nature of polystyrene, polypropylene, that we will have we anticipate somewhat of the same profound success. When you're talking about mixture of plastics and for a minute, let's take out PVC. Let's assume for a minute we have a PVC magnet, because PVC creates all kind of issues. If when we think of the process chemically, we do see the opportunity to produce, to operate on mixture of plastics by the same way that I explained. So in other words, in our work, what we're doing, we're subjecting each I'll say compartment in the reactor to reactions that we feel will only operate on the designated material. And so overall, we can imagine the operating of on mixture of plastics. However, it is not as easy as it sounds. It does need some learning curve, and it requires more attention from our end and more work that we will do. And this is the work that we aim to do with customers.
At your current burn rate, how much runway does the $3 million provide you?
We have enough money to finish our goals, to reach our goals and finish the year. Anything beyond that is, of course, we'll consider going forward as we'll reach our milestones and move on into considering, I'll say, strategic opportunities. Other than that, we're fully funded right now to perform milestone A, demonstrated the bitumen, do everything that we want right now. We will consider, different rounds in the right time, with the right partner, at the right price.
Thank you. Do any of the competitors, public or private, also use a licensing model?
That's a great question. So most of just think of it for a minute from the profound change that the technology could represent. If most of the technologies that we are talking about are, somewhat, let's say, pyrolytic or heat-based, then it implies to a certain way of operating. What you need to do is to work on vast volume, vast amount of quantities, and then if the technology, let's say, and I'm not saying not efficient, all hands down, you have to respect other operation. It's just limited by some chemical and economical realities that are coming to us today because of society and other issues. But you would see how they need to lock themselves into some kind of an offtake agreement and build massive projects in order to extract the economic value. By contrast, this technology enable a lot of flexibility. In other words, to provide solutions dedicated to a territory or to a customer. And the customer could be a small customer, and we could maybe serve 2-3 customers at once. And for that reason, for now, we're not aware, in the plastic area, we're not aware of it. In the heavy oil area, we think there'll be different models, but in the renewable areas, they are not competitive, but there are technologies that are offered for licensing. And, you can, there is different types of processing to produce ethanol, by way of example. And some of them are licensed, just technologies that are licensed, but not directly, not right now, not directly. This is a fairly new approach, and the approach we build this approach because of the flexibility that technology enables us. So reimagining the opportunities, why go and nail yourself to a specific business model? Why not just investigate your options while you can at this point of time, and coming with what we think will be more appropriate to the customer to nail as much as deals we could do with customers.
Perfect, thank you. So I'll just blend these two questions together. As far as companies that you may be working with, both at the showroom stage, the pre-pilot stage, and any other stage, can you speak to any of the industry partners that have shown interest to the technology?
We see growing interest from smaller size producers in this plastic space, and the reason being is that some of them are want to just move away from the pyrolytic process. If you're looking into options to create some kind of a circularity, then you absolutely have to look into chemical conversions. Everything else just doesn't give you the credit. And so we have a growing interest with organizations that are interested in that type of circularity and that type of option, and we investigate that we are investigating that path. The petrochemical, the heavy oil market in Alberta is more of a, you know, show us, proof us that this is work. So they've been, you know, scratches on their scars on their back for many years of efforts of doing things, and so much more skepticism. At this point of time, we have to demonstrate the pilot before we're moving into further discussion. And so that they just those organizations has put so much money over the last I'll say 50 years into in the ground building capex, that if you're coming with something, you better come in, you know, with all of the answers, and that they're waiting to see what we do.
Perfect. As far as the plastic recycling process, have you done any testing yet for the bromines and the various flame retardants contained within plastic products? Have you done any testing for that so far? Or no?
So right now, at this point of time, we're looking at the families of plastics, and each family is breaking down. But overall, from what we see right now, you know, based on the families, and we recognize the families of polymers, we've done work on polyethylene. We're doing now work on the polypropylene, and polystyrene is next. And so it's a growing know-how, but the chemistry checks out, and so we know what to do with it. We anticipate you know, some issues, and we also already anticipate some modeling. There is a core know-how that, you know, we didn't speak about it here in the presentation, but think of it, over the last 10 years, we had to, you know, how many organizations would do that? We have to work on, we started with heavy oil, we moved on to renewable, and we moved back into plastics. And think of it, who would do that? It's so diverse and large and huge, but then they are all connected, chemically connected. And once we understood it, we developed this know-how in the house to be able to deal with you know, kind of a range of issues. And I feel quite strong, you know, that at this point of time, that the team that we've built knows how to deal with variety of issues that are associated, not just with plastic, but with bitumen. And I feel we understand it quite good, actually, at this point of time, to our spec. So nothing else. We're not trying to dive into other technologies, but to our level. I think there is a lot of know-how there that will, you know, provide optimism that we will know how to provide solutions.
Perfect. As far as financial backers, can you speak to any of your financial backers, I guess both private and public, as far as grants?
In terms of the grants?
Yeah, so in terms of financial backers, you know, the last 10 years, how has the company been funded? And then, you know, going forward publicly, do you have any strategic finance partners?
So for most of the time, we've been living by private investors, family and friends, and the grants. And I cannot speak highly enough, nor to the government grants that enable guys like us to simply survive and just, you know, stay off the radar. I mean, the equivalent of anyone that will, whatever we have done in the last 10 years in the lab, I could, you know, it's just in a statement and assessment, but I would think that anything nearby would reach way over $50 to $100 million in terms of research. And so that's what they enable us to do with you know, this amount. About a year ago, we met really a strong bankers that are, you know, believing in what we're doing. I cannot say enough about those bankers. We're working very closely with them, and so far they meet every needs of us, and that gives us the confidence that we could do pretty much whatever we need to do in the near future and be funded until we reach our milestones and beyond that. And so the backers are very loyal.
Perfect. As far as the stage of the company and as far as, I guess, the status of your company as a public company, what are your strategies in place to create additional liquidity? You know, obviously, Volt's retained, you have VLP, and then, you know, is the plan to also bring in some other, you know, strategic partners to raise the awareness of your company and your profile?
as we go forward, and absolutely yes, I guess, but it needs to be appropriate. So we believe so far that I believe, you know, crazy old entrepreneur, right, that the company is undervalued. But what we want to do is really to perform at this point of time. We have enough tools to perform, and so we think once performing, there'll be different discussions that are associated with that, and it will open the conversation also to customers. So now you're entering another level of demonstration, and so all of this needs to come. We anticipate all of this to come after the, you know, us achieving the milestone A, and perhaps after us demonstrating the showroom and enabling, you know, calling for customers to come with samples to test the technology. But yes, I think so.
Perfect. And so if anyone has additional questions, we'll answer them here. If not, you know, any additional questions can always be sent to Craig at ir@adurocleantech.com. And if not, if we don't have any additional questions, we will end the presentation. When the showroom units are up and running, you know, is there any additional expenditures to have those showrooms up and running, or is that factored into your, you know, your projection for covering a year of costs?
Yeah, this is a great question. For most of the time, people used just to build a pilot, and you know, people would come and see, drink coffee, and says, "Oh, good," and you know, move back and going on with the day. When we say showroom, we build a program, and the program is about you know, a 2 months program per customer in general, and so you can have in different way, in different scenarios, you can have 6 to 8, depending on what they're doing in each demonstration session. And with each demonstration session, the customer is actually paying for the sample, for the work we're doing. And so we don't anticipate just showing it at our expense. We actually anticipate we will earn some money out of it. Will be a, you know, a modest cost, but when you're thinking of you know, assume for a minute the customer is very much interested in your option. Assume for a minute that this is very, very new, and he needs to go back and consider what to do, you know, how to digest us, what training, what site preparation needs to do. All of those, what product he's putting in, what's the value of the product that, you know, is being produced. Can we answer some troubleshooting? This is really an investigative mode, one-on-one with the customer, and we envision it will take more than a month, 2 months, basically, as I mentioned. And for that reason, we actually think with every customer that we will build in, there'll be some kind of a revenue out of it. We don't think it will cost us. We actually think we'll see revenue to cover those costs. And it makes sense in the way that, you know, if I'm saying that technology is fairly new, it's only 10 years old in a world where, you know, things has started to happen 100 years old, that a customer will be curious to check the limitations, not just in general, but its own feedstock, you know, because it implies back to the customer benefit, possible benefit. So they would not want to miss that.
Perfect. So no, thank you everyone for attending today. So here you'll see the contact information for Craig, ir@adurocleantech.com, as well as his phone number. Feel free to call or email anytime. If not, too, you can email Volt at ir@voltstrategic.ca. This presentation will be posted as soon as possible, and an email will be sent out to all attendees with a copy of the presentation, the link, as well as additional contact details. Feel free to reach out anytime if anyone has questions or concerns. We're always here to try and, you know, interact with investors and help them learn more about this company. We think it's a great opportunity. But thank you everyone for attending, and you know, thank you to Abe and Ofer for presenting today. And like I say, any questions at all, please don't hesitate to reach out to us.
Thank you very much for everyone.
Thank you, everyone.